Welcome guys to the first session on IB MYP Grade 8 Math. For this lesson we will be going over divisibility rules and prime factorization. So our problem today is on the top left corner of this page. Find all of the prime factors of 4,620, no long division. To do this, we're going to use the factor tree. First, let's do some review on prime numbers. Prime numbers are natural numbers, so integers larger than 0, that are only divisible by the number itself and 1. Similarly, when we solve for the prime factors, we would be looking for all of the prime numbers that multiply together to form the original number, which in this case is 4,620. For convenience purposes, all the prime numbers under 20 have already been listed here, near the top of this document. Okay, so let's begin creating our factor tree, starting with the original number, 4,620. For me, the first thing I notice is that this number ends with a 0. Now, looking at our divisibility rule chart over here on the right, we now know that 4,620 is divisible by 10. Put that on the chart. On the other branch, it would be 462 because 4620 divided by 10 is 462. Okay, but when we check over our list of prime numbers, 10 isn't on there because 10 is made up of 2 and 5. So let's write that under 10. Now let's look over our list of divisibility rules on the right-hand side from top to bottom. Starting with 2. A number is divisible by 2 when it's even. Well, we know that 462 ends with a 2, so yes, it's divisible by 2. Now we're going to move down to 3. But remember, this does not necessarily mean that the number won't be divisible by 2 again. Because say we have a number like 8. Well, it's divisible by 2, and then 2, and then 2 again, right? But working down the list without repeats first is just so we can check over a few more different prime factors to see if they fit. Back on track now. If a number is divisible by 3, the sum of all of its digits must be a multiple of 3. So now our current number is 231 because we just divided 462 by 2, and 2 plus 3 plus 1 is 6, which is divisible by 3. So yes, that's another prime factor of 4620 right there. So 231 divided by 3 is 77. Let's continue moving down the chart. Skip 4 for now because it's a composite number. Skip 5 because we used it once already. Skip 6 because it's composite. Again, this does not mean 4, 5, 6 won't repeat, right? Okay, so we're on 7 now. According to the chart here, a number is divisible by 7 if the result of doubling the last digit and subtracting that from the rest of the digits is a multiple of 7. So in this case, the last digit is 7. Double that is 14. Subtract 14 from the rest of the number, which is 7. We get negative 7, which technically is a multiple of 7. So 4,620 is also divisible by 7. So divide 77 by 7, we get 11. Why 77? Because that was 231 divided by 3. Okay, now let's reference the prime numbers listed above. Is 11 prime? Yes, it is. So now we have completed our factor tree for 4,620. Let's circle all of the numbers on the bottom set of branches. These numbers are the only ones that matter now, because they should all multiply together to form the original number, which is 4620. Another important thing is, when you're in a test or just some practice session, you always want to check your answer. There are 2 steps to this. First, because this is a question on prime factorization, you need to make sure the numbers circled are all prime. Next, it's to make sure that these numbers circled do in fact multiply together to form the product of 4620. After you've checked these things, you can now write down your answer. So 4,620 is equal to 2 times 2 times 3 times 5 times 7 times 11. So there you have it. Hopefully you've learned how to work with prime factorization, the factor tree, and divisibility rules. So down below in the comments section, I will be linking a divisibility rule chart and 2 of Troy Faulkner's videos on actually proving these divisibility rules. I think these are really useful and helpful for later on in providing some insight on how to justify different formulas and to understand how they work instead of just learning them and memorizing them. So for those who would like an extension, these videos are going to be linked down in the comments section. So please like and subscribe to this channel for more exciting and useful content, and see you next time.